Sketch the graph of each hyperbola, label and list all pertinent information. I've made a list of all the pertinent information that we are going to need to find. So let's begin. X squared divided by 4 minus y squared divided by 5 is equal to 1. First question, how does it open? Well, x is the positive term, which means this opens to the right and left. Okay. Center, nothing being added to x, nothing being added to y. The center is at 0, 0. Personally, as I find a piece of information, I like to go ahead and graph that piece of information. So my center is here at 0, 0. All right, for vertices, the vertices will be whatever the square root of this number is. Square root of 4 is equal to 2. So that tells me I go 2 to the left and right. However, the hyperbola is opening from the center. So 2 to the left and 2 to the right. You'll notice I did not label my center. And that's because I don't want to put a C because C is so closely associated with the foci. So we'll just know that that's the center there. I'm going to go ahead and label these while I'm here. Those are at -2, 0 and +2, 0. You could put plus or minus 2, 0. That would be fine. All right, the next piece of information that I'm going to identify is the slope of the asymptotes. Well, I remember that the slope of the asymptotes is equal to positive or negative the square root of the 1 under y over the square root of the 1 under x. So positive or negative square root of 5 over 2. Well, excellent. And I'm going to sketch the graph of that. Now, that's an exact answer, which it needs to be, but it's not too helpful for graphing, so I'm going to get a decimal approximation for this. That's equal to about 1.1. So remember that the asymptotes pass through the center. So from the center, I can think of that as 1.1 over 1 if I'd like to. So I'll go up 1.1 over 1. Up 1.1 over 1. And I'll sketch in that asymptote. There is a positive and a negative version of that, so I'll go up 1.1, left 1.1 as well. I could go down 1.1 and right, and I will sketch in this asymptote. Okay, so we've got those graphed. The next thing we're asked about is the equation of the asymptote. So the equation, remember we're going to use point slope form. Here's the center. That's the point I'm going to use. Here's the slope. I want to use the exact version. So y minus the y part of the ordered pair is equal to m times x minus the x part of the ordered pair. The point slope form of an equation is really, really important in calculus, and oftentimes students prefer the slope-intercept form for understandable reasons. It gives great information, but let's use this as an opportunity to review point slope. Well, as it turns out, this easily simplifies. Ordinarily you wouldn't need to, but since x minus 0 is just x and y minus 0 is just y, why not? So either one of these are fine. That one's fine. That one is super fine. Next on our list of things to do, let's use spring green. So foci are C away. So I'm going to come up here. Ooh, that's hard to see. Let's use ugly green. C squared is equal to A squared plus B squared. Well, c squared would then be equal to 4 plus 5. C squared is 9, which means C is 3. My foci are 3 away from the center. So I'll call that foci distance. So I'm going to go from the center to the left 3. 1, 2, 3. Focus. From the center to the right. 1, 2, 3. Another focus. Okay, these are going to be on the inside of the curve, so that makes sense. I'll write their ordered pairs now. That's -3, 0, +3, 0. And then we have our axes to draw. Remember that the transverse axis passes through the foci and the vertices and the center. So here is our transverse axis. I'll call that TA. That's a horizontal line passing through 0, y equals 0. And then we have our conjugate axis, which is passing perpendicular to the transverse axis through the center. There's my conjugate axis. Vertical line, x equals 0. We still have not drawn the actual hyperbola. We're about to. I lost my pink. There it is. All right. So when you are graphing these for class, for things that you're turning into me, you may go with exactly this, and you're just going to draw a curve headed out towards your asymptotes. The asymptotes indicate the direction that the hyperbola will be curving. So we want to go out towards these. Try not to make them curve back in. I kind of did on that one. They're going to continue to approach, getting closer and closer and closer to these asymptotes. Now on Alex, however, you are sometimes going to have to give other ordered pairs. Well, no worries. All you have to do is make yourself a little table. Pick an x value, plug it in. So we'll say pick an x and then solve for y. And you could just find different ordered pairs. Now, but use your graph to choose sensibly. You wouldn't want to choose like x equals 0 or even x equals 1 or x equals 1.5 because the graph doesn't pass through those x values. So you'd want to choose something more than 2 or less than -2. All right, next example. Y is first. That means this opens up and down. The center, I've got an H and a K this time, but be careful, H is always with X. So my center is at 2, -3. The vertices will be the square root of 4, which is 2 away from the center. So I will go 2 up and 2 down. Vertex, vertex. So those are located at 2, -1, and 2. I was at -3, I went down 2, so that's -5, 2, -5. The slope of my asymptotes will be positive or negative. Square root of the 1 under y over square root of the 1 under x, 2/3. So I will go up to right 3, sketching that in, and then I will go up to left 3, sketching that in. There are my asymptotes. The equation of my asymptotes will be y minus the y part of the ordered pair, well, minus -3 is +3, equals positive or negative 2/3 times x minus the x part of the ordered pair, x minus 2. The foci will be located at c squared equals a squared plus b squared, or square root of 13. So they are square root of 13 away from the center. Well, the square root of 13 is about 3.6. So from the center, I will count up 1, 2, 3.6. There's a focus. And I will count down 1, 2, 3.6. Another focus. I'll label these points. Now I was at 2, -3 for my center. I moved up and down square root of 13, there it is, away from the y value. So it's going to be 2, because my x value stayed the same, -3 plus or minus the square root of 13. Equation of the transverse axis. My transverse axis is passing through my focus, my vertex, my center, all the way down. There's my transverse axis. And it is going to have an equation. It's vertical, so it's going to be x equals, and it's passing right through 2. X is equal to 2. My conjugate axis will pass through the center, perpendicular to the transverse axis, and it is a horizontal line, y equals, going right through there at y equals -3. I will sketch in my hyperbola passing through the vertices, heading out towards my asymptotes. And if I wanted more points, I certainly could find them by plugging in x values and solving for y.